Hello students, this is Mr. Ross. I won't be at school today. However, I got a video for you to explain today's lesson. This is today's lesson. It's about solving exponential and logarithm equations. At the end of this lesson, you should understand how to solve simple exponential and log equations, solve more complicated exponential equations, and solve more complicated logarithmic equations. You should also understand how to use exponential and log equations to model and solve real-life problems. Alright, so let's get started. There are several great properties that you have to understand. One property is the one-to-one properties. That means that a to any power equals a to some other power, meaning that those two powers or exponents have to be the same. So this is called my base, the a is, and this is also still the base, as in base, B-A-S-E. If these bases are the same, then the exponents also have to be the same. And that's just a truth about mathematics. Now, a new word you're going to use is logarithm, and we abbreviate that as log. If I got a log base a of x equals to a log base a of y, if both of these say log, and both of these bases are the same, and those are the only numbers in my equation, then x has to equal y. So it's only true if x and y are the same numbers. So that can be useful in solving equations. The inverse properties as well. This is 1. If I have log, a base a raised to the log base a of x, then it equals to x. Notice how this base is a, and the base here in the exponent is also a. If both of those numbers are the same, then these essentially cancel each other, leaving just the x as the answer for it. So those be x. And that goes in reverse. If I have a log base a of base a to the x, well, that equals x as well. Basically, if this base and that base is still the same number, it cancels each other, leaving just x, but it's not an exponent anymore. It looks like the last one, it's the whole number, and it's also the answer. Alright, so let's begin by solving some exponential equations without using logarithms. And these equations you might see on the SATs or ACTs, and they expect you to do without a calculator. Alright, let's begin with the first example. It says 5 to the x power equals to 125. Well, you make it think, well, 125 is actually a perfect cube. It's actually 5 to the third power. So if that's true, since both bases are 5 and both exponents are x and 3, then the exponent here has equal this exponent. So I know that x has to equal to 3. That's a pretty basic one, just understanding that those can be written to the same base. Base is 5 on both. So that's pretty great if you can see that. If you ever see those, you expect to kind of rewrite that as a base. All right. The second one isn't as obvious. What it says is 2 to the x plus 10 equals 4 to the 3x plus 1. I'm going to change the color. So I looked at this again. I'm going to rewrite 4 so the base is the same on both sides. So I can rewrite 4 as 2 to the power. So I can rewrite this as 2 to the x squared plus 10 equals a 2 squared to the 3x plus 1. So since 4 is 2 to the second power, this is going to be 2 to the second raised to that same exponent. From there, we have an exponent property rule that says we have a power raised to a power. You multiply these exponents. So this side of the equation becomes 2 to the 6x plus 2, because you got to multiply 2 to both of those. You distribute both. All right. So if that's true, I could make a new equation. I'll put it down on the next line. It says 2 raised to the x squared plus 10 equals to 2 raised to the 6x plus 2. Since both of these exponents are both of these bases are 2, this is base 2, and that is also base of 2, I can make the exponents equal to each other. So that means that this exponent has equal to this exponent. So my equation now says x squared plus 10 equals a 6x plus 2. And this is a quadratic equation that you guys have learned to solve in this school year. You get one side equal to 0, and then begin isolating, and then begin solving. So I'll subtract 6x from both sides, and I'll subtract 2 from both sides. All in one step. This would cancel the 6x's and cancel the 2, give you the new equation that says x to the second power, subtract 6x, 10 and subtract 2 gives you plus 8, equals a 0. And if you remember factoring, I'll be looking for two numbers multiply together to be 8, and add to be 6. So it's going to be x and x. I've got a like sign, so they both subtract. And two numbers multiply together to be 8, add to be 6. We got 1 and 8, 2 and 4. 2 and 4 is definitely a pair that can add to be 6 if they're both negative. So negative 2 and negative 4. This should be a 4. And I thought create this would be a 4. I can say each of those factors equals to 0. So it's going to be x subtract 2 equals 0. X subtract 4 equals 0. So I know that one solution is 2. And the other solution is 4. So I got two solutions. One solution is positive 2, other solution is positive 4. I'll check to make sure no solution is not extraneous or something like that, but if I'm looking at it, and this should be okay because you shouldn't have an extraneous solutions for those. So with that said, those are pretty basic ones where you can rewrite the exponents or rewrite the equations so it's a base being the same on both sides, and then you can set the exponents equal to each other after you make the bases the same. All right, now let's talk about how this relates to logarithms in my next video.